Hello everyone, welcome to Susan and John MathTube, and we are back with some shortcuts to answer multiple choice questions really fast. And that's going to give you a huge advantage in your engineering entrance exams. And today we are going to learn how to differentiate implicit functions within seconds. Yes, you heard it right. You can differentiate implicit functions within seconds. But before we start, you should be very good in something called partial differentiation. Yes, my friends, that's a tool. Once you learn how to differentiate partially, you will be able to differentiate implicit functions within seconds. And that's going to give a huge advantage for your engineering entrance exam. So let's start. And as always, I'm going to ask, are you ready with your pen and paper? If not, pause the video and get a sheet of paper and a pen. Okay, so what do you mean by implicit functions and what do you mean by explicit functions? The simple definition is, if you have something like y is equal to sine x, it's called an explicit function because y is completely given in terms of sine x. At the same time, if you have something like x square plus y square plus x into y is equal to a square, it's called an implicit function because all the variables are mixed up. One variable is not given in terms of the other variable. So, to make it simple, if all the variables are mixed up and you are given an expression in x and y, we call it an implicit function. And in your class 11 or 12, you might have learned a very lengthy procedure to differentiate such functions. So we are going to bypass all those steps. So let's learn how to differentiate functions partially. So consider the function f is equal to x square plus y square. If you want to differentiate f partially with respect to x, the trick is you imagine x is the only variable in the expression. Just imagine there is only one variable and that is our x. So what will be the derivative with respect to x? And that will be 2x plus, of course, everything other than x will be treated as constants. So you're going to end up with 2x. And if you want to differentiate partially with respect to y, you imagine this expression has only one variable and that is y. That means every variable or every letter which you see in the function other than y will be treated as constants. So it's very easy, 0 plus 2y and that will be equal to 2y. Okay, so let's go for one more example. Let's say we have a function x square plus x into y plus y square. So what will be the partial derivative with respect to x? Yeah, when you differentiate with respect to x, you imagine x is the only variable. That means all the letters other than x will be treated as constants while differentiating. So the derivative starts like 2x plus. Okay, tell me, how do you differentiate 5 into x? Of course, the derivative will be 5 into 1. Okay, we have y into x. And I told you, when we differentiate with respect to x, x is the only variable. That means y will be treated as if it's a constant. So the derivative is y into 1 and finally 0. That's it. So you're going to get 2x plus y. And if you want to differentiate with respect to y, you imagine y is the only variable. So the derivative will be 0 plus x into 1 plus 2y. Well, the answer is x plus 2y. Once more, we'll go for a last example. Suppose we have f is equal to x cube plus x square into y plus a square. Don't forget, we are going to differentiate partially with respect to x. 3x square plus y is a constant when we are differentiating with respect to x. So you end up with y into 2x plus 0. And if you differentiate with respect to y, that is, we are going to assume y is the only variable in f. So the derivative will be 0 plus x square into 1 plus 0. Okay, so I hope you're okay with partial differentiation. Now let's move ahead and check the shortcut. So look at this. We have an implicit function. Are you sure it's an implicit function? It's an implicit function because all the variables seem to be mixed up. One variable is not expressed as a function of another variable. So definitely it's an implicit function. And if you remember the procedure from class 11th or 12th, you know it will take at least one page for you to find the derivative. Now let's move ahead and look at the shortcut. So I want dy by dx. So the first thing I'm going to do is I'll put a negative and I'll put the division symbol. Now for the numerator, you just differentiate this expression. Okay, first of all I'm going to take everything to the left side, so I'm going to get something like this. So now I want you to differentiate partially with respect to x, and that's going to give me 2x plus y plus 0 minus 0. For the denominator, you differentiate partially with respect to y. That is, you assume y to be the only variable. So this will be 0 and this will be x into 1 and then 2y and finally minus 0. That's it, my friends. You have the derivative right in front of you. Now let's try one more question so that the method becomes more clear. So we have an implicit function over here, and I am sure that you have seen the same question in your class 11th and class 12th books. Okay, and it takes a long time if you go for the actual process. So let's go for the shortcut. So as before, write dy by dx equal to, put negative and let's make a big bracket, and shall we start? Okay, the first thing to do is take this a cube to the left hand side, so nothing, it will become minus. So we have an expression here. Okay, differentiate this expression partially with respect to x. That is, assume that x is the only variable. So we have the numerator 3x square minus 3ay into 1 plus 0 minus 0. Now for the denominator, you assume y is the only variable. So we start with 0 and then minus 3a x into 1 plus 3y square. That's it. You can take those three common. So you'll end up like this. Isn't it easy? Okay, let's make the method really clear. So I have a long expression which represents pair of lines, etc., etc. Okay, so shall we start? So now you tell me, what's the first thing to do? Okay, let's write dy by dx is equal to, and then put minus, and then a big bracket, and then divided by. So what are you planning to do first? Yeah, differentiate this expression with respect to x. I mean partial differentiation. So you're going to get a into 2x, because we assume x to be the only variable, plus 2hy into 1 plus 0 plus 2g into 1 plus 0 plus 0. And for the denominator, you assume that y is the only variable, that is, differentiate partially with respect to y. So this is a constant 0. So 2h x into 1 plus b into 2y plus 0 plus 2f plus 0. That's it, my friends. You have the answer right in front of you. So here it goes. So did you like the trick? Okay, now let's go for some more serious questions. And before we start, I hope you're good with these formulae. So the derivative of x power n, that means variable to the power number. I'm sure you know the formula. And the second one, number to the power variable, and a and n are constants, x is a variable, and ln a means log a to the base e. Okay, please read the question. If a power x plus a power y is equal to a power x plus y, find dy by dx at 1 comma 1. Means you have to put x equal to 1, you have to put y equal to 1. So I have the formula over here. So the first thing to do, take everything to the left hand side, and then you write dy by dx and put negative. So shall we start differentiating? Okay, so tell me, for the numerator you assume x to be the only variable. We differentiate partially with respect to x. So a to the power x. So what's the derivative? A power x ln a. And a power y, of course, is going to be 0 because you're differentiating with respect to x, that too partially. Minus, for the last one, we get a power x plus y ln a. And then the derivative of x plus y will be 1 plus 0. And for the denominator, we differentiate partially with respect to y. That is, we do differentiate in the assumption y is the only variable. So you're going to get a similar expression, ln a minus a to the power x plus y ln a, and then 0 plus 1. Okay, that's it, my friends. It's done. You have the derivative right in front of you, but we want the derivative at 1 comma 1. So let's take this ln a common and cancel it so that you get something like this. Now tell me, what will happen if you put x equal to 1 and y equal to 1? Think about it. Don't write. I know you have pen and paper with you, but in an entrance exam you have to save time. So don't write. So if I put x is equal to 1 and y equal to 1, yeah, I'm going to get the same thing in the numerator and the denominator. So these things are going to get cancelled, and my answer will be equal to, minus 1. And that's it. Now shall we go for one more question, a little bit more complicated. So here we go. So the question is, if e to the power xy plus xy is equal to 2, what is dy by dx? But before we start, I'm going to ask you one question. What is the derivative of e to the power ax, where a is a constant and x is a variable? Yeah, that will be a into e to the power ax. I'm sure you know this result. And we have a very beautiful implicit function. Okay, the first thing to do, take everything to the left hand side. Now the next thing, we put dy by dx is equal to negative and then a big bracket and our division. And let's change color. So tell me, what is the partial derivative of e to the power x into y with respect to x? That is, you assume x to be the only variable. That means y is a constant. So you're going to end up with y e to the power xy. So that's it. Y e to the power xy plus, what about x into y? That will be y into 1 and minus 0. In the denominator, you are going to differentiate and you assume x to be a constant, or y is the only variable. So you're going to get x e to the power xy plus, tell me, what's the partial derivative with respect to y? Yeah, that will be x into 1. Okay, that's it. Take common. I guess you have something in common here from the numerator y and from the denominator x. That's it. Okay, let's move ahead and learn one more type. So sometimes in the entrance exam you will see patterns like this. That is, y is equal to root under f plus root under f plus root under f plus dot dot dot. And this f actually stands for a function in x. And my friends, you don't have to waste your time making it implicit function, squaring on both sides, then differentiating. Just go for the ready-made formula dy by dx equal to f dash by 2y minus 1, where f dash stands for the derivative of f. Okay, let's try one question. So take a look at this. Y is equal to root under sine x plus root under sine x plus root under sine x plus dot dot dot. The question is dy by dx is equal to question mark. It's very easy, my friends. I want you to connect our question with this standard format. So tell me, what will be dy by dx? You can answer in seconds. What is the derivative of sin x? Yeah, cos x. And that's it. The denominator will be 2y minus 1. That's it, my friends. That's it. So shall we try one more question? Yeah. Same thing. Are you able to see the pattern? Root f plus root under f plus root under f plus dot dot dot. And instead of our f of x, we have log x. And the derivative of log x is 1 by x. So just match it with the standard pattern. Dy by dx will be, the numerator will be 1 by x. The whole divided by 2y minus 1. And remember, I was assuming log x to have base e. Okay, so on simplification we get this. That's it. Now let's learn one more very important pattern which comes regularly in the entrance exams. That is, y is equal to f of x to the power f of x to the power f of x to the power f of x. Of course, it goes to infinity. And in such cases, the derivative will be y square by 1 minus log y to the base e f dash by f. Or you have one more format, and the notations are over here. Ln f of x means log f of x to the base e. F dash stands for the derivative of f of x, and f of course is our f of x. So let's check one question related to this format, and that will be the last question in this video. So let's move ahead. Yeah, we have this. Y is equal to tan x to the power 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 tan x dot 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 dot. It goes on like this. No need to worry. The actual procedure is you will call the repeated function part to be y, then you'll take logarithm, then you're going to make it into an implicit function, you're going to differentiate, you'll keep on differentiating, simplify, and finally you'll get the answer. But my friends, for engineering entrance exams, time is really precious. So I want you to match this with the standard pattern over here. So what will be dy by dx? Okay, what is the derivative of tan x? Yeah, sec square x. So dy by dx will be y square by 1 minus log y to the base e or ln y, and then sec square x the whole divided by tan x. That's it, my friends. We have the answer. So I hope you enjoyed all the tricks, and today's tricks were related to differentiating implicit functions within seconds. But you need a lot of practice. Take any book which you like and try to use these shortcuts for those problems. Anyway, as always, if you want us to make videos related to any particular topic in mathematics, then feel free and email us at sjmathtube@gmail.com. And in the next video, we'll be back with more tips and tricks and more shortcuts to answer multiple choice questions really fast. So till then, bye.